Something huge is about to pass within 170 million miles of Earth, traveling at 153,000 miles per hour. That makes it the fastest comet ever recorded entering our solar system. But here's what NASA isn't emphasizing enough. This object is behaving strangely. It's erupting. It's brightening in ways that shouldn't be possible. And some of the data is so unusual that it's forcing scientists to question whether we understand interstellar objects at all. This is 3I Atlas, and on December 19th, it's making its closest approach to our planet. What you're about to hear is going to make you question everything. Let's start with the most unsettling fact: the speed. When 3I Atlas was first discovered in July 2025, it was clocked at 137,000 miles per hour relative to the Sun. That's already insane fast enough to cross the continental United States in less than 90 seconds. But as it fell toward the Sun, accelerated by our star's gravity, its speed increased to 153,000 miles per hour at perihelion. To put this in perspective, that's 42.5 miles per second. If you blinked, it would travel 8 miles. Nothing we've ever tracked moves this fast through our solar system. The previous interstellar visitors, Oumuamua and 2I/Borisov, were slower, much slower. So why is 3I Atlas moving at such an extreme velocity? The leading theory is terrifying in its simplicity. Something ejected this object from its home star system with tremendous force. Either a close encounter with a massive planet, something Jupiter-sized or larger, or a catastrophic event like a stellar collision. Whatever happened, it happened with enough violence to hurl this comet into the void at escape velocity, and it's been accelerating through the darkness ever since. But speed isn't the only problem. 3I Atlas is on what's called a hyperbolic trajectory. It's not orbiting. It came from interstellar space, swung around our sun, and is now leaving forever. The trajectory is so steep, so fast, that our sun's gravity can't capture it. Now here's where things get weird. Comets are supposed to follow predictable paths based purely on gravity, but 3I Atlas isn't. As it outgasses as jets of vapor blast from its surface, those jets act like tiny rocket thrusters, subtly changing its course. Astronomers are tracking what they call non-gravitational accelerations. The comet is pushing itself off course, not by much, but enough that scientists have to constantly update its predicted position. Why does this matter? Because these jet forces tell us the comet is active, violently active, and that activity isn't slowing down even as it moves away from the sun. In late October, as 3I Atlas passed behind the sun from our viewpoint, something happened. The comet brightened, not gradually, sharply. A lasting surge in brightness that persisted for days. At first, scientists thought it might have fragmented, broken apart like some comets do when they get too close to the sun. But when it emerged from behind the sun and became visible again in November, it was still intact, still erupting. High-resolution images from Spain's Joan Oro telescope revealed the truth. Massive spiral jets blasting from multiple points on the surface. Gas and dust streaming into space in organized, rotating patterns. This wasn't normal outgassing. This was cryovolcanism, ice volcanoes. Multiple vents across the surface simultaneously exploding as buried carbon dioxide ice sublimated and reacted with metal grains in the comet's core. Some researchers believe the entire water-ice surface layer erupted at once. The whole thing. Imagine a comet the size of a small mountain suddenly activating like a bomb. That's what we're looking at. Here's something that's genuinely unexplainable. 3I Atlas has two tails. Most comets have a dust tail that points away from the sun, blown by solar radiation pressure. Normal. Expected. But 3I Atlas also has what astronomers are calling an anti-tail, a plume of material pointing toward the sun. This shouldn't exist. The physics don't support it. And yet there it is, visible in multiple observations. Some scientists think it's a perspective illusion that we're seeing a curved tail from a specific angle, but others aren't so sure. One possibility: the violent cryovolcanic jets are propelling material in directions that don't follow normal comet behavior. Another possibility: the comet's rotation is so complex that material is being flung in unexpected directions. Or, and this is the option nobody wants to say out loud, there's something about this object we fundamentally don't understand. So on December 19th, this fast, erupting, trajectory-altering comet will pass closest to Earth. At 170 million miles away, there is zero collision risk. NASA has been absolutely clear about this. But here's what should concern you. We don't fully understand what 3I Atlas is. We don't know its exact size. Estimates range from 1,400 feet to 3.5 miles across. That's a huge margin of error. We don't know why it's brightening the way it is. We don't know why the anti-tail exists. We don't know if cryovolcanism will intensify or stop. And here's the kicker. After December, it'll be too far away to study in detail. We'll have months more of faint observations, but the critical data collection window is now, right now. Telescopes worldwide are racing to gather every possible data point before this thing vanishes into the cosmic dark forever. Let's talk about what this means. If a comet this active, this violent, this fast came from another star system, what does that tell us about that system? What kind of planetary environment creates objects like this? The answer is unsettling, a chaotic one. A system where massive planets gravitationally dominate, where collisions and close encounters are common, where smaller bodies are routinely ejected at extreme speeds. It's possible 3I Atlas comes from a binary star system, two stars orbiting each other, where gravitational interactions are far more violent than in our relatively calm solar system. It's also possible this comet was ejected during the death throes of its star system, a red giant phase, a planetary collision, something catastrophic. The point is, 3I Atlas didn't gently drift into interstellar space. It was violently thrown. And now it's here, tearing past us at record speed, erupting as it goes, carrying the scars of whatever destroyed its home. December 19th. Mark it down. The fastest, most violent interstellar comet ever recorded will make its closest pass by Earth. You won't see it with the naked eye. It'll be too faint. But telescopes will be watching. NASA will be watching. And somewhere, in the data streaming back, we might find answers to questions we didn't even know to ask. Or we might find more mysteries. More reasons to wonder if we're ready for what else is out there, drifting through the darkness between stars, waiting to be discovered. This is 3I Atlas, and it's almost here.